Okay, chapter 6.4, surface area of pyramids. Now, a pyramid always has triangular sides, and they're called lateral sides. But the base always has a shape. The simplest is a triangular base, but the easiest is a rectangular base, and in this case it's a square-based pyramid. Alright, so the nice thing about the base is if it's a regular equilateral figure, this one, each side is 6. The base, this is an opened up pyramid. It's like they're hinged along the bottom and all of these sides just flop out onto the ground. Alright, that's kind of what we're thinking about. There's lateral height. This is a slant height. This is not how tall the pyramid is from the ground. This is how long this edge is from the middle of the side to the top, to the pinnacle. Okay, so to find the surface area, again, we're just adding them all up. The first thing we have to do is, it's the area of the base, the S, surface area equals the area of the base plus this area of the lateral faces. I'm going to run out of room. Okay, so we got the area of the base plus the area of the lateral faces. And when there's a rectangle or a square bottomed pyramid, which is a square pyramid, that's the nice way to say it. If it's rectangular pyramid, it might not be a square. We want a square pyramid. This is the bottom. So the area of the base is just area equals length times width. 6 times 6 is 36 centimeters squared. Plus the area of the lateral faces. And in this case, so it's going to be surface area equals 36 plus, now that this triangle here is 6 by 12. So area of a triangle is 1/2 base times height. Hopefully you remember that formula. And this triangle has a base of 6 and a height, and it's a straight up and down height. It's this height is 12 centimeters. So the area is 1/2 of times 6 times 12. 1/2 of 6 is 3, and 3 times 12 is 36. So the area is 36 centimeters squared of the triangle. But we have now that's pretty interesting how that worked, because it's 36 for the square, and then it's also 36 for each of these 1, 2, 3, 4 lateral faces. So there's 1, 2, 3, 4 of those plus the original, the base. This is the base, and this is a lateral face, a lateral face, a lateral face, and a lateral face. 4 of those. Really, it's just 36 times 5 for the surface area. And we'll figure out what that is pretty quick on the calculator. 36 times 5 is 180. So the surface area is equal to 180 centimeters squared. Alright, so that's what that looks like. Now sometimes we have something like a triangular pyramid. It's a little harder to draw, and I'm not going to draw it very well, but you can kind of see that there's a base that has 3 sides and then 3 lateral faces. And if we were to draw that all flopped out, it would look a little bit like this, if I can draw it correctly. And it's not going to be perfect, but I hope you forgive me. So the middle one is the base, and then you got your 3 edges, your 3 lateral faces. Now sometimes, let's see if I can make it, let's draw it a little bigger. Okay, so say that the base here is 10 meters, and then the height of the triangle, which is the perpendicular distance from the bottom to the vertex is 8.7 meters. Hopefully you can see that. That's why I had to go bigger. Okay, and then we have each of these edges coming out. And this might be different too. This could be a different length. Let's say it's 14 meters. And because we have a equilateral triangle for the base, that each one of these is 10, 10, 10, 10, but this distance across is 8.7. If we were to draw it this way, it would also be 8.7, and this way it's also 8.7. So once we see that we have all of these pieces taken care of, all we have to do is find the surface area of the base, the area of the base, and then the area of the three lateral sides, which should all be the same, and add those together. So the base, I keep doing that. Let's clean it up. There we go. Let's change the color just for fun. The base is just area of a triangle. Area equals 1/2 base times height, which is equal to 1/2 times 10 times 8.7. 10 times 8.7 is 87, and 1/2 of that would be 87 divided by 2. Let's just get out the handy calculator again, just so that we can check ourselves here. 1/2 times 10 is 5 times 8.7, so it's going to be a little bigger than 40. Equals 43.5 meters squared. And then the area of the lateral faces that is again, the area of a triangle is 1/2 base times height. I'm going to drive that in until you remember it. 1/2 times the base here is 10, and the height is 14. And this one I can do in my head, because if I cut 14 in half, I get 7, and 7 times 10 is 70. Or if I were to do half of 10, which is 5, and 5 times 14 is also 70. Alright, and so that's going to be 70 meters. And then I have to remember that there are 3 of them. So to do the surface area, I end up with 43.5 plus 70 plus 70 plus 70, or 70 times 3, which is 210. Because 7 times 3 is 21. So 7D times 3 is 210. I hope that makes sense. Plus 43.5 is 253.5 meters squared. And that's how you do a triangle. Okay, and it's an equilateral triangle. If you start getting into triangles that are other shapes on the base, if the bases are odd shapes, then your sides are not going to all be the same. And that takes more work, but I think we're going to keep it a little bit easier and keep the bases simple. So you're going to basically have to work with squares and equilateral triangles for this one. If there's something else, they're going to give you the shape. If it, like for instance, if it was an equilateral pentagon, which hexagon, can't do it. If it were an equilateral hexagon, they'd give you the sides. They'd give you the area of the base, say like 100 centimeters squared, and then you'd have to figure out the area of one of the triangles and multiply it times 6, because there would be 6 of them around the edge. Okay, something like that. Pretty easy. Have fun with this.